Alright, click on Code Tour, click on the play button to the right to start the tour. Should be interesting. Follow the instructions outlined in each step. You'll be inserting code and running commands in the ID terminal. Click Next to advance through the tour. Ooh! Alright, step 1. Creating and deploying a Terraform configuration. The VPC directory will store the Terraform config file. When it's time to initialize, plan, and apply your changes, the Terraform command will run from within this directory. We'll be inserting code into the main TF file to continue. So main TF, insert the code below into the to configure the AWS provider. Is that it? Right, then what we're doing with it. So we just insert the code, click Next.
The thing is, I like working with independent hour people or small HR companies. Cause the difference between them and big corp hour departments. Insane. One will read your CV 5 times and still not understand what you do, while the other reads 2 to 3 lines from your CV and already knows exactly what you do for work.
This is quite cool. I didn't even know you could do this, like Code Tool. Right, the Terraform resource block configures various settings for Terraform. Starting with the version 13, required providers block was introduced to describe the version and source of the Terraform providers. Providers allow Terraform to communicate with remote systems. In this case, the AWS provider connects to AWS and creates the resources on your behalf. Use HashiCorp. AWS source indicates that you're using an official HashiCorp provided provider. Version set to 5.9. Setting the provider version is important due to the frequent potentially breaking updates provided by the AWS provider. So setting the file, you can pin this functionality specifically to the version, avoiding updates negatively impacting your project. Click Insert Code to add the following provider resource block. So that adds a region. Next. The provider block is used specifically to authenticate AWS to a region. This will authenticate to US West 2. EC2 hosting this IDE environment has been granted permission to the AWS environment and is passing the credentials through the provider. Terraform is authenticated by accessing the IAM role permission granted to the EC2 instance. Insert the following VPC resource config. Insert. The resource is configured with a second lab VPC label. This label is used to identify a specific VPC resource. These labels allow resources to be identified within the config file and are useful when more than one instance of a resource exists. The CIDR block identifier is used to explicitly set the CIDR block with the VPC. Argument specifications for each resource block can be found in the Terraform documentation for each provider. The CIDR block argument is an example of an optional argument used to configure the resource. Depending on the resource type, AWS provider will create and apply changes to the resource using certain default values. If a value is not present for the argument, cool. Right, insert the following template outputs to complete the TF file. Why doesn't it insert code? is so dumb. Alright, outputs are commonly used to pass variables between modules. In this lab, you're introduced to the outputs of the way of displaying a VPC attribute upon deployment. After a successful deployment, the ID, root table ID, and security group ID attributes will display in the terminal. These values did not have to be explicitly defined in an example of automatic provisioning, which takes place under the hood. With the VPC config complete, we can begin the deployment process. The first step is to initialize Terraform. When you run Terraform init, the specific version of the AWS provider is installed. It will create a Terraform lock file to record the provider settings. Click on the following command to initialize Terraform. And then the Terraform plan command will provide you with the required changes that will be applied to the infrastructure. Most of the VPC attributes are known after applying. When you run the plan command, Terraform will return as much information as it can predict about the deployment. These values are typically non-deterministic, such as IDs, specific to the platform, or are randomly generated. The plan field will outline the number of resources to add, change, or destroy as part of the deployment, and adding one resource. So we apply. That's applied, so we've got our VPC and the root tables and the security groups. Yep, apply is complete. It will follow with the output values. You can also use the CLI describe VPC command to confirm the deployment. So that gives us back the actual AWS CLI result. So you've successfully deployed the VPC using Terraform. We can finish the tour. And I can start my check.